Hello, AP Stats students, and welcome to AP Daily Live Review for AP Statistics. My name is Luke Wilcox. I am an AP Stats teacher at East Kentwood High School in Kentwood, Michigan. Now, I hope you got a chance to join my colleague, Darren Starnes, in session 5, where he talked you through some very important resources for preparing for the AP Stats exam. Now, here in session 6, we are going to focus in on the free response portion of the AP exam. Now, here's why I think this is so important. Now, not only are you going to have to understand the content and have some skills, but more importantly, on the free response, you are going to be graded on your clear communication of your understanding. And in order to be able to do that well, you have to understand how the question is going to be graded on the other end. So we are going to spend a lot of time today talking about the rubrics used to grade the free response. And I'm going to tell you exactly what is necessary in order to get full credit. In addition to that, I am going to present some very common student errors that we typically see when we are grading these on the AP exam. So let's go ahead and jump right in. A few logistical items to take care of up front here. There is a tiny URL that you can go to here in order to access some digital resources that will be helpful to you during this session. If you go to that URL, you will find a handout specifically for this session. So this is session 6. You're going to want to find that handout and download that. You could print it. The idea here being that you are going to be engaging and following along with me as I help you through some of these questions. Now, in addition to that, you'll also find the formula sheet and tables, the actual formula sheet that you will be given on the AP Stats exam. I am going to reference that a couple of times when we're going through a few of the questions. Now, let's talk about what we are going to learn in this session here. So I'm going to start with the overall goals, and these are the same goals that we have for every one of these sessions. The first of which is to review essential content and skills. And for this session, that is going to span the entirety of the whole course. So way back to data collection methods, all the way through statistical inference, we're going to do a significance test today. Our second goal is to share specific strategies for AP exam success. All of those strategies today are going to be around the free response portion of the AP exam. And then finally, probably the most important goal here is that we're trying to help you build your confidence so that we can increase your AP exam score. Now, how are we going to accomplish these goals? Well, here is the plan for the session. First, we are going to work through 3 free response questions from a recent exam. So these are real deal AP questions, and they've been chosen very intentionally here to highlight some of the important things that are on the rubrics, as well as to highlight some of the common student errors that we see. And part of what we're going to do in this session is to talk specifically about those rubrics and those common student errors. So for each one of the 3 free response questions, I'm going to present a model solution. Then we're going to talk through the rubric that would be used to grade that model solution. And then finally, some common student errors associated with that question. So let's go ahead and jump right into the practice. So here is the first free response question. It says, researchers will conduct a year-long investigation of walking and cholesterol levels in adults. They will select a random sample of 100 adults from the target population to participate as subjects in the study. Part A. One aspect of the study is to record the number of miles each subject walks per day. The researchers are deciding whether to have subjects wear an activity tracker to record the data, or to have subjects keep a daily journal of the miles they walk each day. Describe what bias could be introduced by keeping the daily journal instead of wearing the activity tracker. So take just a moment to think about what approach you might take to this question. Now, as I look at this question, I'm identifying one word in here that I think is what this question is really all about. It's all about this idea of bias. And if we think about the definition of bias, it's something in the data collection process that would result in us consistently overestimating or consistently underestimating the truth or the true value that we're trying to estimate. And there are definitely a couple directions that you could take this answer. More important than what you decide is the problem with the daily journal is your explanation as to why that is a problem. So I'm going to present to you one potential model solution here. It says, if subjects kept their own journal, many may lie and report more miles than the truth to make them look more active. An activity tracker would report the truth. In this case, the estimate of the mean daily miles walked for the target population will be higher than the truth. So that's our model solution, but maybe more important here, we want to understand what the rubric would be looking for and to see the certain parts of this solution that would satisfy that element in the rubric. So let's take a look. The first component that is needed on the rubric says, indicates a journal could result in bias that would be avoided using activity trackers and provides a reasonable explanation. So now where is this in the model solution? Well, I've highlighted it in blue here. You can see we said in the model solution that many may lie. So that's identifying what the bias is. And the reason why that's biased is because it will make them look more active. That may be the reason why they're lying. Whereas an activity tracker would just report the raw data, which would be the truth. So we've satisfied the first component there in the rubric. Now the second component says systematic, consistent underreporting or overreporting of daily miles walked, or the estimate is biased, underestimation or overestimation. Now, where did we include that in the model solution? You can see here, we've said that we would report more miles than the truth, and that would lead to an estimate that is higher than the truth. So when you're looking at this rubric here, I actually think that there are 3 items that are important to include anytime you're asked a question about bias. I want to make these very clear to you. The first one that I see here is just in identifying the bias. So I'm going to say the first component here is that you want to identify the bias. And that could be some special vocabulary term like undercoverage or non-response, or you could just sort of explain the bias in words. But then the next part of this here is to provide an explanation as to why that creates bias. So the second thing here is explain why that is creating the bias, because people are lying because they want to look more active. And then the third part here, which you see in component 2, is about indicating what I call a direction. So the estimate that is going to be gathered using this method is going to be an underestimate or an overestimate of the truth, and you have to provide that explanation or that direction there. So you may not look at this question and think that there are all 3 of these things that are necessary, because the question just says describe what bias. But you should know that anytime a question is asking about bias, you're going to want to include these 3 things: identify the bias, explain why it creates bias, and then give a potential direction. Now let's talk about a couple of common student errors here. Now the most common student error that we see on questions like this is that students will identify the bias, and they may even do a good job of explaining why that creates bias, but they forget the last part, which is to indicate the direction. So you want to make sure that somewhere in your response, you're saying something like lower than the truth, or higher than the truth, or underestimate or overestimate, to make sure that you are indicating the direction. Now let's move to the next part of the question. It says, during the course of the study, the subjects will have their cholesterol levels measured each month by a doctor. The researchers will perform a significance test at the end of the study to determine whether the average cholesterol level for subjects who walk fewer miles each day is greater than those who walk more miles each day. Part B, selecting a random sample creates a reasonable representative sample of the target population. Explain the benefit of using a representative sample from the population. Okay, I have a little bit of a diagram here that's going to help before we look at the model solution. And the idea is this. I'm going to start with a picture of a big cloud here, and let's let that big cloud represent this target population. So all of the individuals in the entire population are contained within this big cloud here. Now we are going to take a random sample here and hope that it creates a representative sample. Well, the idea of a representative sample is that it looks like the larger population. So I'm going to draw a smaller cloud here, which would be our random sample. And because this is a smaller cloud and it looks like the bigger cloud, any data that we collect from the random sample should be representative of the larger population, allowing us to then do some inference about the population, taking what we know from our sample and making some inference about the larger population. So here's what this would look like in words in our model solution. A representative sample allows us to generalize the results of the study to the target population, allowing us to make inference about the relationship between cholesterol levels and miles walked for the target population. Now let's take a look at the rubric and try to figure out where we are getting our credit in this model solution here. So the first part of the rubric says that we need to explain that a representative sample is needed to generalize to the target population. Well, we said that in the first sentence here, where we said generalize the results of the study to the target population. Now the second part of the rubric says that we need to refer to estimating or making inference for cholesterol levels in the target population. Well, if you look at the model solution, we did that right here where we said make inference about the relationship between cholesterol levels and miles walked for the target population. Now, here's what I think this second part of the rubric is getting at. This idea of cholesterol levels is what many call the context of the question. So it is very important that when you are writing up your answers to free response, that you are including the context of the question. What is this question actually about? This question is about cholesterol levels and miles walked. So as a general rule, when you are writing your responses on the free response, you want to try and include as much context as possible. So you don't want to give some sort of general statement. You want to make it specific to the context of that particular problem. All right, let's talk about a common student error that we see here. And that is this. Many responses discussed a benefit of using a representative sample in general terms and not with respect to this study. Meaning the context was left out. So a student might say something like, so that we can generalize, or even so that we can generalize to a population or the target population, but they didn't say anything about cholesterol levels. So in general, you want to make sure that you include context. This is going to be a common theme that you're going to see all throughout this session. All right, moving on to part C. It says, suppose the researchers conduct the test and find a statistically significant result. Would it be valid to claim that increased walking causes a decrease in average cholesterol levels for adults in the target population? Explain your reasoning. Okay, a couple of important ideas that I see here. First of all, the idea that we have a statistically significant result. Now that means if we did a significance test, we would have gotten a p-value that was less than our alpha level of significance. So that means something's going on here, right? We have a statistically significant result. But as I read through the rest of the question, I think I've identified the most important word here, and that is the word causes. We are trying to decide if we can say that increasing walking causes a decrease in average cholesterol levels. And thinking about this here, the problem is that we have simply observed these values. We did not randomly assign people to be in two groups, long walkers and short walkers, and then see what happens in the end. We just simply observed each person. And so this is definitely an observational study, and it is not an experiment, which means that we cannot show causation. You have to have an experiment with random assignment to treatments and a statistically significant result in order to talk about a cause and effect relationship here. So here's what the model solution is going to look like on this one. It says no, because this was an observational study. A causal relationship can only be established when using random assignment of treatments in a properly designed experiment. Now, what parts of this are needed for full credit? Let's look at the rubric. The first part of the rubric says, indicates that a causal inference cannot be made. Now, this is just a tiny part of our solution. It is the first word which says no. And that is answering the question that is being asked here. If you look, the question says, would it be valid to claim that, etc.? You got to answer the question. So the answer to the question here is no, and that's part of the rubric. The next part of the rubric says that there is an explanation based on one of the following: a lack of random assignment, being an observational study and not an experiment, or the third one here, possible confounding variable. Now, if you look at our model solution, I think we actually have 2 out of the 3, even though we only need 1 out of the 3. That first one, the idea of lack of random assignment, you can see that in our solution. And then you also have being an observational study and not an experiment. And you see that part of the model solution. So we really only needed to have 1 out of those 2. Now, this third possibility that you see here says possible confounding variable. So another approach to this that would get full credit would be to identify a specific confounding variable here. So a confounding variable is some other third variable besides the explanatory and response that's sort of making it difficult to see whether the explanatory is causing the response. In this particular context, someone might say that the initial health of each one of the subjects might be a possible confounding variable. Now, very important, if you're going to go this route and you're going to talk about a confounding variable, you have to make sure that you link the confounding variable to both the explanatory variable and the response variable. In this case, the explanatory variable is the amount of walking. So in order to make a link here, you might say something like, if somebody has an initial health that's very good, they're very healthy, then they probably already walk a whole lot. Now that's connecting to the explanatory. The response variable that we're measuring here is the cholesterol level. So you'd also have to connect initial health to cholesterol level. Something like someone who's initially very, very healthy might already have low cholesterol levels to start with. So that is the third possible way that you could get that second component. Now let's talk about some common student errors on one like this. The first one is that some responses indicated it was valid to make a claim about cause and effect because there was a statistically significant result. So very common when students see that it's statistically significant, they think, oh, that means we can show causation. Well, that's not the case. In order to be able to show a cause and effect relationship, you have to have a statistically significant result and random assignment in a properly designed experiment. So statistical significance by itself is not enough. You also have to have the random assignment. The next common student error is that some responses did not clearly indicate whether the answer was yes or no. So this is where you have to make sure that you answer the question that is being asked. And this is a question that really requires a yes or no answer. All right, let's move to free response question 2, part A here. It says, to increase morale among employees, a company began a program in which one employee is randomly selected each week to receive a gift card. Each of the company's 200 employees is equally likely to be selected each week, and the same employee could be selected more than once. Each week's selection is independent from every other week. Part A, consider the probability that a particular employee receives at least one gift card in a 52-week year. Part I, define the random variable of interest and state how the random variable is distributed. So the first thing that we need to do here is to identify what type of random variable we have. And looking at the question, it's asking about at least one gift card in a 52-week year. And it sounds to me that it's something like counting the number of successes out of the 52 weeks. And to me, that sounds like it could potentially be a binomial distribution. But just to check to make sure, let's think about the 4 conditions that are required for a binomial distribution. And we remember those with the acronym BINS. So the first condition, B, stands for binary, which means each trial could be considered a success or failure. Well, in this case, each week could be considered a success if you win the gift card and a failure if you don't win the gift card. So that first condition is satisfied. Now, I stands for independent. And it does say right in the question that each week's selection is independent from every other week. And we're also sampling with replacement here because an employee could win more than once. So our second condition is satisfied. The third condition, N, is that we have a fixed number of trials here. And the fixed number of trials is that there are 52 opportunities to win the gift card here. So that is our fixed number of trials, n equals 52. And then S, we have the same probability of success for each one of those trials. Well, if each of the employees is equally likely to win, that's a 1 out of 200 chance. That is the probability that we would win on each individual trial here. And that is equal to 0.005. So I think we have a binomial distribution here. And for a binomial distribution, the random variable is measuring the number of successes in the fixed number of trials. And so here's what our model solution looks like. It says X is the number of gift cards won by an employee in a 52-week year. X is binomial with n equals 52 and P equals 0.005. Now the next part of part A, part II, says determine the probability that a particular employee receives at least one gift card in a 52-week year. Show your work. Okay, let's think about this idea of at least one gift card. So at least one gift card, if we were to write this as a probability and using our random variable X that we just defined, at least one is X is greater than or equal to 1. And if you think about that, greater than or equal to 1, well, that would include getting exactly one success and getting exactly 2 successes and 3 successes and so on. Now, we can't possibly calculate all of those individual probabilities. So it's going to be helpful here to use the complement rule. And the complement is like, what don't we want? Well, if we want 1 or more, the thing that we don't want is the probability that X equals 0. So we can simply do 1 minus the probability that X is 0. So here's our model solution. The probability that X is greater than or equal to 1 equals 1 minus the probability that X equals 0. Now we still need to know how to calculate the probability of getting 0 successes out of 52 trials. Now for this, I'm going to jump over to the formula sheet that's provided on the AP exam. And on this very first page here, if you look about halfway down, there are some formulas there for binomial distributions. And the one that we're going to want right here is the formula for calculating probability of a certain number of successes there. That's the binomial formula. So we're going to use that binomial formula here in order to calculate the probability that X equals 0. So here's the numbers plugged in to the binomial formula. And we're going to get a final answer here of 0.2295. Now pay attention here, this value, that was the probability that X equals 0. And we did 1 minus that in order to arrive at our final answer here. Now let's take a look at the rubric to see if we have everything that we need to get full credit on this one. So I've just gone ahead and copied all those answers over here. So this is our model solution, but now let's look at the specifics of the rubric. So the first thing we need is to correctly define the random variable. Well, we did that right away when we defined X as the number of gift cards won by an employee in a 52-week year. The second thing we need is to identify the random variable as binomial with n equals 52 and P equals 0.005. Well, that's the second thing that we did in our solution here. The third part of the rubric is to give the boundary and direction for the event. Now, this is the at least one gift card, and we use some notation here to indicate the boundary, which is 1, and the direction, which is greater than or equal to 1. And then finally, the correct answer with work here. So it is not just about coming up with that final answer that is correct. It is also about having the supporting work to arrive at that answer there. Now, part B says, calculate and interpret the expected value for the number of gift cards a particular employee will receive in a 52-week year. Show your work. So looking at this question here, I see that we're looking for an expected value. And I know that that's the same as asking for a mean. So what we really want here is the mean of the binomial random variable. Well, let me jump back over to my formula sheet here and zoom back in on the binomial section. And you can see there is a formula there for calculating the mean, or the expected value, is n times p. So that's the formula that we're going to need in order to calculate our expected value here. And then we're going to have to interpret. So using n times p, 52 times 0.005, we get 0.26 gift cards as the expected value. And here is the interpretation. If the company repeated this gift card selection process for many years, each employee would win 0.26 gift cards per year on average. Now let's make sure that we hit everything on the rubric. The first thing that's needed is the correct expected value, once again, with work. So this is not just about the correct answer, but it is also about showing the calculation that arrived at that. Even if it's a simple calculation, we're just multiplying 52 times 0.005. We want to make sure we include that work. And the second part of the rubric is a reasonable interpretation that includes at least two of the following: the concept of repeating the selection over a long period of time, the concept of an average or mean, and the context of gift cards. So you're going to see we actually have all three of those in the model solution, even though we only need at least two of them. So the first idea, the concept of repeating the selection over a long period of time, well, we said many years there. The second one, the concept of an average or a mean, we got that right at the end when we said on average. And then the third one, the context of the gift cards, we provided that right here as a unit attached to our expected value. So this is the second time now that we're seeing context showing up in the rubrics. So once again, anytime you can include context in your responses, you're going to want to do that. All right, let's talk about some common student errors on this question here. The first is that students interpreted the expected value as a probability. And I think the reason that happened was because we got a decimal value here for the expected value. And a lot of times students see decimals and they think automatically that it's a probability. But this is an expected value, it's a mean, it is not a probability. Now, another common student error is that students will round expected values, either down to 0 or up to 1, thinking to themselves that, well, you can't win 0.26 gift cards. Now, that's true for one individual, but for an expected value or a mean, you certainly can have a decimal, and it should stay as a decimal. This value should not be rounded. You're going to want to leave that as a decimal anytime you're calculating a mean or an expected value. And then the third one here, the expected value is an average after many years, not many weeks. Remember, this binomial distribution has n equals 52. That's 52 weeks. That's 1 year. So it's saying if we did this for many, many years, the average number of gift cards that would be won would be 0.26. All right, let's move to the next part of the question here, part C. Suppose that Agatha, an employee at the company, never receives a gift card for an entire 52-week year. Based on her experience, does Agatha have a strong argument that the selection process was not truly random? Explain your answer. Okay, now there are two different directions that this one can go and still arrive at full credit, both of which are referring back to some work that we did earlier in the question in part A and part B. If you recall, in part A, we did calculate the probability of somebody winning 0 out of the 52. And so we used the binomial formula there, 52 choose 0 times the probability of success raised to the 0 times the probability of failure raised to the number of failures. And if you look at this formula here, the first part of it, 52 choose 0, well, that's actually just 1. And then anything raised to the 0 power is really just 1. And so what we end up with here really is 0.995 raised to the 52. And that's going to give us the answer that we got in part A there, which was 0.7705. So about a 77% chance that that would happen. There's a 77% chance that an employee would win 0 gift cards out of 52. So this whole thing with Agatha, not very surprising. So here's what the model solution looks like. No, with a fair lottery system, employees would receive no gift cards about 77% of the time, which is quite often. Agatha's result is not surprising. So let's see what the rubric looks like for this one here. The first component is to indicate that Agatha does not have a strong argument. Well, we did that with one word, the first word of the solution, that is the word no. This is another case of answer the question that is being asked. And this is really a yes or no question that needs to be answered here. And so that's the first part of the rubric. The second part of the rubric is to provide a relevant probability or expected value. Now, we went the route of calculating a probability, and that was the 77%. So there's our relevant probability. And then the third component says to link that probability or expected value to the decision. So that 77%, we had to link to the decision, and we had to say that that was quite often. And so Agatha's result is not surprising here. Now, there was one other approach that you could take on this problem that would still get you full credit, and you see it in the rubric here, this idea of expected value. Well, this is what we did in part B of the question. In part B of the question, we calculated the expected value, and that expected value was 0.26 gift cards. So on average, over many, many years, an employee would expect to win about 0.26. So the fact that Agatha won 0, that's not really surprising here because the average is 0.26. So we would say something like Agatha's result of X equals 0 is not surprising because that expected value is so low there. It's close to 0. So you could have also gotten full credit on this one using your answer from part B. Now let's talk about a common student error that we saw on this one here. And that is giving a correct probability, but not linking it to the decision. So the student might calculate the 77% or calculate the 0.26 as the expected value, but then not saying anything about why that answers the question here. And I think at some point you have to say that Agatha's result was not surprising based on the number that she calculated. All right, let's move to our final free response question, number 3. Here is part A. It says the manager of a large company that sells pet supplies online wants to increase sales by encouraging repeat purchases. The manager believes that if past customers are offered $10 off their next purchase, more than 40% of them will place an order. To investigate the belief, 90 customers who placed an order in the past year are selected at random. Each of the selected customers is sent an email with a coupon for $10 off the next purchase if the order is placed within 30 days. Of those who received the coupon, 38 place an order. Part A, is there convincing statistical evidence at the significance level of alpha equals 0.05 that the manager's belief is correct? Complete the appropriate inference procedure to support your answer. Okay, so I think the first place we want to start here is to think about the appropriate inference procedure. And so I have a set of questions that I always ask my students anytime we get a new scenario and we know that we have to do some sort of statistical inference with it. So my first question is always, am I in the world of means or in the world of proportions? And looking through the numbers that we have here, we have 90 customers and we are recording whether or not they place an order, 38 of which placed an order. Now that sounds to me like a proportion, that 38 out of 90, that's going to be a sample proportion. So I definitely know that I'm in the world of proportions. Now, the next thing to consider is whether we have one sample or two samples. And reading through the scenario here, those 90 customers, they were selected at random. That is really the only random sample that I see here. And so we know that this is a one sample scenario. And then the final question is this a confidence interval or is this a significance test? And anytime you see the wording convincing evidence, you know that that is going to be a significance test. And you're also given a significance level here. So this is definitely going to be a test. And so put all those things together, and we definitely have a one sample scenario. And because we're in the world of proportions, this is going to be a z-test for a proportion. So that is the inference procedure. So one of the first things we want to do is identify that inference procedure. So let's look at the first part of the model solution. I'm going to present the model solution in 3 different parts because that's the way that the rubric is written. So here's part 1, section 1 of our solution. You'll notice that we have identified the type of procedure, which we just talked about, And then we've provided the hypotheses. The null hypothesis says that P is equal to 0.40, and the alternative says that P is greater than 0.40. Now, this means this is a one-sided test, and there is some wording in the question that indicates why this is a one-sided test. If I go back to the question, we see that the manager thinks that more than 40% of them will place an order, more than 40%. That's exactly what you see right there in the alternative hypothesis. Now, the other thing that's important when you write your hypotheses, you're going to be using a parameter that refers to the whole population, and you have to define that parameter. And so that's what we see here. We're defining P as the proportion of all customers who would place an order within 30 days after receiving a coupon. Now, let's check in with the rubric for section 1 and make sure that we have everything we need here. So the first thing that we need is correct hypotheses. Well, we definitely have that. Our null hypothesis says P equals 0.40, and we talked already about why it's one-sided for the alternative. Secondly, we have to have sufficient context for the parameter, including the idea of the population, customers, place an order after the coupon. And so you can see we have that right up top when we've defined our parameter. And this idea of all customers is what makes it about the whole population there. And then we also have more context about receiving the coupon. The third thing that we need on the rubric is the correct name for the procedure. And that could be by writing out the actual name, or later you could get that by using a correct formula. Here, we just wrote out the name of the inference procedure, one sample z-test for a population proportion. So let's talk about some common student errors on this first part of the significance test. One that we see quite often, you're seeing this again, it's about context. You got to have enough context. So just saying something like customers may not be enough. You want to include as much context as is given to you in the question. Another problem that we see often is that in identifying the parameter, students will use past tense. So they may say something like proportion of all customers who placed an order, right? Who placed an order. Now, the reason why past tense doesn't work here is because if we said who placed an order, it sounds like we're referring to the sample. And we know that a parameter refers to a population. So we typically don't want to use past tense when we're defining a parameter. And then the third one, incorrect notation in the hypotheses. And most often for a significance test about a proportion, a student might use p hat, which is incorrect here. You always want to use the parameter when you are writing out your hypotheses. All right, let's take a look at the second part of the solution here. This is section 2. And what we're going to do here is we are going to check our conditions and then find our test statistic and our p-value. So the conditions that we've checked here is the random, because we have a random sample of 90 customers. The 10% condition, because we are sampling without replacement. So we want to know that the sample of 90 is less than 10% of the population of all customers. And then the large counts condition, we want to check that n times p and n times 1 minus p are both at least 10. And here we have 36 and 54. Now, the other thing that we need to do in section 2 is to give the test statistic and the p-value. And so I'm going to jump over to the calculator. Now, you could do this by hand with a formula, but I'm going to use the calculator to find those two values by going to stat and then over to tests. And this test that we're doing right now is a one proportion z-test. And I've already got all the information preloaded here. Our null hypothesis is 0.4. The number of successes was 38 out of 90. And then our alternative says greater than the p null, which is 0.4. And I can go right down to calculate. And this is going to give me my z-test statistic of 0.43 and my p-value of 0.33. So let's go back to the question and record that z-test statistic as well as the p-value. Now let's check in on the rubric for section 2 here. So the first thing we need is to make sure that we check the random selection and the 10% condition. Well, that's the first two things that we've indicated here. Next, we need to check the large counts condition, n times p n times 1 minus p, both need to be at least 10. Done. And then the third and fourth components, the actual calculation here, is the z-test statistic as well as the p-value, which we got from the calculator as 0.43 and 0.333. We have all four of the components needed for full credit. Now let's talk about some common student errors on this section right here. The first one, and we see this so often on the AP exam, is that a student writes random check. Now that is not enough. Okay, the condition, the random condition, can be satisfied in a couple of different ways. If it's a one sample problem, you're going to have a random sample. We need to know that it's a random sample. If it's a two sample problem, you might have independent random samples, but you could also have random assignment in an experiment. And so it is important that you indicate whether this is a random sample or a random assignment. In this case, we have a random sample of 90 customers. The next common student error is using the sample proportion to check the large counts condition. So the sample proportion here, p hat, that was the 38 out of 90, which was about 0.422. And sometimes students will incorrectly use that value here when they're substituting in for n times p and n times 1 minus p. Remember, when you're doing a significance test, you assume the null hypothesis is true, and the null hypothesis here said that p is equal to 0.40, which means you should use that p equals 0.40 when you are checking the large counts condition. All right, we are to section 3, the final section of the solution here. And that's where we're going to make a conclusion for the significance test. It says, because the p-value of 0.333 is greater than alpha equals 0.05, we fail to reject the null hypothesis. We do not have convincing evidence that the manager's belief is correct. Now let's see what is needed for full credit on the rubric. The first thing is a correct decision by comparing the p-value to alpha equals 0.05. Well, the correct decision here is to reject the null hypothesis. So we have that. And we have to do that by comparing p-value to alpha. Well, we definitely did that. P-value is greater than our alpha level of 0.05. So you definitely want to have a comparison there, greater than or less than, when you're comparing the p-value to the alpha level, as well as your decision. Next, correct conclusion that is consistent with the alternative hypothesis. So this is the second sentence that we provided here, which is making a claim about the alternative hypothesis in context. And in this case, we do not have convincing evidence that the alternative is true, that the manager's belief is correct. Now, some common student errors when it comes to conclusions for significance tests. The first of which, a big no-no in AP statistics, is accepting the null hypothesis. So we said that we do not have convincing evidence that the manager's belief is correct. That is not the same as saying we know that the manager's belief is incorrect. That would be accepting the null hypothesis. So every time an AP exam grader reads a student response where they accept the null hypothesis, a small tear comes down the side of their face. Please don't do that to the AP exam graders. Do not accept the null hypothesis. Up next, and you're starting to see a theme here, it's about context. In that final statement, the second sentence, when we're talking about the alternative hypothesis, you need to make sure you put that in the context of the problem. All right, part B, the final part here says, based on your conclusion from part A, which of the two errors, type 1 or type 2, could have been made? Interpret the consequence of the error in the context. Now, in a previous session, we talked about the definition of a type 1 and type 2 error, but let me just remind you real quickly of a type 1 error versus a type 2 error. So for the type 1 error, the null hypothesis is true. And we made an error, we made a mistake. In this case, the mistake would be to reject the null hypothesis. That is a type 1 error. Now for the type 2 error, the alternative hypothesis is true. And this time the error or the mistake would be that we failed to reject H null. So the question here is, which of these errors could we have made in the significance test that we just did? Well, looking back at our answer, what we did here was we failed to reject the null hypothesis, right? That was our conclusion. We failed to reject the null hypothesis, which means the only error we could have made there is a type 2 error. So here's what the model solution looks like for this one. Because the null hypothesis was not rejected, a type 2 error could have been made. The manager may decide not to use the coupon promotion when it actually would result in more than 40% of their customers making a purchase within 30 days. So what's needed here for full credit? Well, the first part's easy. You got to identify the correct error that could have been made. In this case, we said type 2 error. Now, the second part of the rubric is to give a reasonable interpretation of the consequence with sufficient context, like those who would place an order or coupon or sales. And this is our second sentence that we provided here when we said that the manager may decide not to use the coupon when actually he probably should have used the coupon. All right, let's talk about what we should take away from this session number 6 here. So I'm going to go back to the goals from the beginning of the session, the first of which was to review some essential content and skills. And we had a wide range of things that we talked about in this session. The first of which was to be able to describe bias. Remember 3 things: identify the bias, explain why it creates bias, and then give a direction. Next, the purpose of random sample versus random assignment. Remember, the big cloud, small cloud tells us that the random sample is so that we can generalize to a larger population. And then also remember that we need random assignment with an experiment in order to show causation. Up next is the idea of defining random variables. We did this for a binomial random variable, but you could be expected to do the same for a geometric random variable. And then we did several binomial calculations as well as interpretation. So be familiar with the binomial formula, as well as the formulas for mean and standard deviation for binomial. And then we did a full significance test for a proportion and talked a lot about what is required for full credit on a question like that. And finally, at the end, we reviewed the definition of a type 1 and type 2 error, and then make sure that you can interpret those errors in the context of the problem. Now let's talk a couple of specific strategies that I'm hoping you are taking away from this session here. The first of which you saw several times in the session, and that is on the free response, you got to include context, like on every question. Next is to make sure that you answer the question. A lot of times this is very easy by providing a simple yes or no. And then really the whole purpose of this session was you got to know the rubrics, you got to know what they're expecting, you got to give them what they're expecting in order to get full credit. And then finally, the most important goal here, hopefully you are starting to build your confidence as we are getting closer and closer to the AP Statistics exam. So I hope this session 6 was helpful for you. I certainly also hope that you will join my colleague Darren Starnes for session 7, where he is going to take you through the most important free response question on the AP exam, the investigative task.